Welcome back to another of my YouTube video tutorial. In this video I'll be looking at 2017 CSEC Past Paper question. So this question asks that we draw to a scale of 1 to 50 using appropriate building conventions the sectional elevation AA. Label the following important elements in the section, not elevation. So we need to see floor, slab and foundation footing, external and internal walls, windows, doors, ceiling and roof. Specifications, these are very important. Foundation reinforced continuous strip footing, 200 by 600. Foundation wall, 200. Floor, 125 millimeter thick concrete slab. And these are the dimensions for the doors, windows. Ring beam, minimum height of finished floor, the top of ring beam, 2,600. So this is the floor plan, the outline for the floor plan. And the building, the first thing we need to do is to turn the paper in the direction that the arrow turns. The next very important part, we need to identify the points where the cutting plane line cuts the walls. In this case, it cuts the wall here, it cuts through a window, it cuts through a door here, it cuts through a next solid wall, a door here, and a patio. Looking in this direction, we should be seeing a door here, you should be seeing a window, and the patio railing. To get started, we also need to take note of the type of roof we have here. All right, so the first thing to do is to, in this case, would be to establish the ground level, and from the ground level we need to offset a distance equivalent to the finished floor to the ring beam. Finished floor to ring beam. Then from here down, the depth of foundation can range from a low of 300 to up to 1200 millimeters. 1,000 is a good value. Now we need to establish that this has 3 levels. Here is the foundation, elevation, and up here is the roofing detail. Roofing details. Now, first we'll start by drawing a wall from here. And the wall thickness, in this case, 150. From that wall, so we have drawn this wall. Next we go across and we draw this wall here, which would be someplace here. I think I started my first wall too thick, but it's okay, never mind. Next we cut here. And the wall thickness. Then we cut into this other door here. It should go over into this. And out here we have the patio. Now, the next thing that we could start with is our ring beam. The ring beam is typically 150 by 300. We offset this. So in AutoCAD, I typically draw this at the outside of drawing, and then copy and paste it into all these spots. So we have that across all of those. Next, we would need our wall plate. Wall plate is typically 100 by 75 or 80. So we will draw our wall plate, copy and paste it into these locations. One wall plate there. Next wall plate there. Now we need to determine the roof shapes here. As you can see, the cutting plane line cuts the roof at 1 along the ridge line here, or very close to the ridge line. Cuts it here, very close to the ridge line, and here. In this case, I probably would assume that it cuts through the ridge line, but they don't want to distort the broken line here, so they draw it right there. So for the roof, this would touch at 1 along here, 2 and 3 and 4. If the cutting plane line cuts the roof at 4 locations, or it runs through the ridge line, then it must be drawn this way. Must be drawn this way, as opposed to if it was to cut across here, where it cuts the roof at 1, 2, 3 points, then we would have a V, a roof looking something like this. So something we need to take note of on the elevation, how the roof actually cuts. Again, if the cutting plane line touches the roof at 1, 2, 3, 4 points, then we have something like this. If it cuts it at 3 points, 1, 2, 3, then we use a V roof. Now let's move on. Once we have done that, our next step is to draw a line through there, then offset this to get the rafter, and the overhang would be something like this, 450. Now to determine how high the roof is, what we do, we typically draw a line equivalent to this distance and draw this at an angle. So you could draw a line like this, draw this at 30 degrees, which is a typical angle for the rafters, the roof to pitch. If the roof pitches 30 degrees, we draw this at 30 degrees. So this length would be the width. So you could draw a line at 30 degrees here, at 30 degrees here, and where both of them meet, we transfer this distance, and this distance will determine the height for this. So let's go ahead. We could mirror this on the other side if you're using AutoCAD. This here, that there. Now assume that this is a certain amount. We would then draw our line here. We will then offset this to that amount, whatever this distance is, whatever this distance turns out to be. And again, we get this distance. This should be at 30 degrees or whatever distance, whatever angle you're giving to draw the pitch at. So assume that this is that much, we draw that to that. Then we offset this to that distance of the rafter. We get that. Then of course we're gonna add our different layers. So this is then we offset this by 25 for, well, it depends on the type of roof. In this case, this is for this question, I think it's a in this case the roofing is a sheet metal on a 50 millimeter purlin on 50 by 100 and 100 millimeter rafters. So we would need to add our purlins. One there, one there. And this is typically at 850 millimeters. Then we draw, and we'll do the same thing across here. Remember, these are 50 by 50. They should be square. And of course, that going across. And we would then place our sheeting material over here. One layer to represent that. Then our fascia board would be here. Our fascia board would be under here. And our soffit under here. Now, assume that this is the finished floor. Yeah, from the finished floor, well, if this is a ground level, it depends on where you use this line, because if this is a floor line, then the slab and the screed would be above this. So let's assume that this is a finished floor. That would be the screed. Below the screed we have the concrete. Below the concrete we have the hardcore. Remember that you must use the correct symbol for the different materials. Below the hardcore we have the earth. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3. And down here we have the footing. And of course you would draw the steel work in here and the convention for that. Now from here we have a window. We could draw a window here. From the finished floor to the top of the window should be 2100. And above that we have the lintel. The lintel is 150 by 150. Now for the window, we would need the window framing, or is it vertical window, top of the window, sill height. And I use this for the window. Further across we cut in, so this is the cut into a window, cut into a door here. So this one, same 2100. ring beam up there, and the detail for the door would be there. We have the top rail, middle rail, bottom rail, and door stop would have been out here. Door stop detail there. Hatch for this. So we will go through and do the same thing for these. In this case, I'm just doing only the first one. So looking from here, we're looking into a solid wall here. Here is a conference room. Conference room. Here is the bathroom there. We have a wall here. A wall here. So we use a line to represent that. To represent the wall here. Going across here, we have this door. And wall here. Next we have a section showing next door, and that door here. So we would drop in the detail for the door here. And out here, here you have a patio. And for the patio, we have a railing here. Oh, I think one wall is missing. 1, 2, 3, 4. I think this should have been. Oh, I think 1, 2, 3, 4. 1, 2, 3, 4. That edge or that edge, that or this edge right here. I think one is missing right there. Then we would have this railing here. Yeah. So then we would have a rafter here. The rafters would be these would be 50 millimeters wide at 600 millimeters on center. So this would basically be the detail, the sketch, the sectional sketch for this joint.